download everything. We are live. Indeed, we are live. We're here. I look kind of different. Let me fix my hair, and maybe that'll be better. Also, I'm trying a new angle. This elevated angle. I don't know if I like it or not. What do you guys think? What I've done here is put my phone camera on the can of chickpeas that was too big for me to open. There were two such cans, and I struggled and fought with one and opened one and ate one. The other one indeed is the camera holder at this time. Hopefully. Harper! Hello, my love. How are you doing? Goodness gracious, it feels like I haven't seen you in forever. It feels like I haven't seen me in forever. Here I am, here I am, here I am. It feels like it's been a long time indeed that I have been live because I've been on vacation. I was gone for a few days. I am back in Boston, back in business. Yes, Shona! Fuji's calling me. Fuji! My voice did a weird thing. Fuji-mama! Yes, baby! Oh, hi, Fuji! Fuji, have you brought a toy for me? Sometimes Fuji brings me a toy at this hour. Harper, thank you so much. How are you doing? Say something in the chat so I know you can see me and hear me okay. Can you see me and hear me okay? I feel like it's been so long since I've been on the lives. Yes, indeed, Harper. We've missed you. And we have been wondering where you are, for sure. Thank you so much, though, for being here. Love that little rose in your, or the little flower that's in your name, and your comments and your chat messages here. And I hope that very many of you will join very soon here, both old and new friends. And we can say hi in the chat. We can say hi to everybody who joins. And I can read your chat messages and give you a shout out of your username and such, and channel name and such. Look at us. We are here. We are indeed here. And Fuji is a little mad at me for starting the live right now. Because I think he wanted to play. Fuji, Mama loves you the best of all. Fuji doobie doo. Fuji, Mama loves you so very much. Now he's sitting on a Target bag and being very mad at me. Fuji, Mama loves you. One of my kitties likes to bring his toys in my room. Aw, I think they're bringing you gifts, and they like to bring us gifts. So thank you so much. Everybody, welcome, welcome. Thank you so much for being here. Welcome to all my continents: Asia, Europe, Africa, Antarctica, Australia, New Zealand, North America, South America, everybody, Chile, especially Argentina, Brazil. Where is my Saudi Arabia? Hello, AXL Rodriguez. You look unreal. I went and saw fireworks. Fireworks. Oh, for Memorial Day, you mean? Wait, is that soon? Oh yeah, it is that. It is soon. Hello, everybody. Hello, AXL. What are you saying about the unreal? What do you mean? What do you mean, my friend? Be more specific. And thank you so much indeed for being here. Today we're going to talk about Friedmann equations from cosmology, and we're going to talk about the entire universe, of course. And please do like the live. Please do double tap and like the live, please. Thank you so much for being here. Welcome. Welcome, welcome. If you're from Asia, put a pink heart in the comments. If you're from Europe, put a green heart in the comments. What do you mean all? AXL. AXL has said that we look unreal and disapparated. If you are from Africa, put a red heart in the comments, because I really want to go to Africa soon. Africa, you are in my heart. Hello, Big Goat, Mustache. Harper, let's just try to just see what happens. Let people be. Don't feel like you have to do your mod duties right now. Let me just go through and kind of see what's going on, okay? So just sit back, relax, and enjoy the flight. It's been a hot minute since I've been on here, so I'm kind of getting back into the into the drill here. I accidentally hit the hide button. Yeah, just forget it. Just let them be. Let them say whatever. I really need the watch time, so let them be. Any other inappropriate, weird comments? Go ahead. Go ahead before I become famous. So Harper, how's it been going? How's school? And also, I'm drinking this Coco Vita because it is extremely hot here in Boston. So much so that I may have to use the air conditioning, but I really don't want to turn it on because I'm saving on power bills. Great, the year is almost over. Oh my gosh, that's right. It's May. When is your last day of school? Is it May 20 something? Ooh, and I should share the live. I'm gonna do that. So some of these live streams have been kind of quiet. 22nd. May 22nd. Got it. But that's okay because it's been kind of nice to peacefully do the material and the explanations, and sometimes when people are here there's a lot of interruptions. Not that we don't want people here. We definitely do want people here, but at the same time, it's kind of been peaceful when there's no people. So if you're seeing this later on as a video upload, it may actually be more smooth. If you see this later, and if you are here live, well then, it will be fun. Chickpea! Oh my goodness, Ver, how are you? How are you, my friend? I saw your comments earlier. Here I am. I finally made it. Chickpea Break. Hello, Chickpea Break. Hello, Harper. So good to see you, my friends. I'm great. Oh, good. So today we're going to talk about cosmology, Friedmann equations, and I was telling Harper how we can be super lenient today. I really need the watch time. I'm very close. Hi, Fuji Shona. Oh, Fuji's right here. Come, Fuji. Fuji, do you want to give Mama a kiss? So Fuji, Suji, Baji have been extremely possessive ever since we got back. As in, I got back. Can we get 20 likes? Yes. Pin message. We definitely need 20 likes, but we will see. Fuji. Fuji looks so cute. Fuji, you're so very cute. Fuji, you're so very cute. Fuji, you're so very cute. Oh. Can we get 30 likes? $100 super chat to see Baji. Exactly. Where is our $100 super chat? We need some money to keep this channel running, to be honest. The bills are high. Today I discovered a very high property tax bill, which has been quite a downer on my day actually. I was doing all this math to figure out the math of my life here, and then here we are now. And I'm giving special attention to all my children with the thanks to the universe for all your help, support, protection, blessings, kindness, and guidance to the universe and my kids, for my kids, because they have been extremely upset with me for going on vacation. And ever since I've been back, they have wanted to be on my lap constantly. And here we are. So this is my first live stream since being back. I'll BRB guys, inflation, shout outs, $20 super chat. Thank you guys so much for all your support and your help. Fuji Baba! Fuji is just the cutest. I can't show him because of evil eye remove. I can't show him, he's too cute. He's too cute. Fuji, Mama loves you. Mama loves you. Mama loves you. Okay, as soon as my iPad wakes up, I will, my child scratches me when he makes biscuits. He's a kitty. Aww. As soon as my iPad decides to be a thing again, I will share my life. What is going on? Go away, YouTube, so I can properly open you. Hello, Sarki and Lilith. You're still so beautiful. Still? Jay says cats are weird. What do you mean, J-E-Y? Hello, Jay. Welcome to the live. Hello, Sarki and Lilith. What do you mean still? Was I supposed to become ugly? And thank you so much for your comments, indeed. Oh, by the way, so I went to the Caribbean and I have a lot of bug bites on me. So if you find me to be itching, that's what that is. I am back, a little darker, a little tanner, and with a ton of bug bites. Cats eat there. Actually, I did meet some cats in the islands. It was very special. It was very special indeed. Harper trying to upstage me. Can we get 40 likes? Yes, please. Jay, before you say anything more, can you please like the live? That would be most excellent. Thank you so much. Oh gosh, Mike D is here. Mike D says, I love you. Hello, Mike D. Can you do a super chat of $500 million? What do you mean, chickpea? Says, mine don't eat me, cat eat their owner. You know, I want that because I want my kids to be well fed at all times. So, I bless them to do anything that they need to. I say still because every time I come back, you're still looking gorgeous as ever. With 4 orange hearts. Oh my goodness. Thank you, Sarki and Lilith. Thank you so much. Oh. Fuji! Fuji's laying down. Fuji. Oh, you're so cute, my bacha. 1 second, guys. You're so cute. Look at that. It's okay. Fine. I'll show you for a little. He's so cute. He's so cute. You're so cute. You're so cute. Where's Reese and Doro? Make me a moderator, says Mike D. Dora was right about you, Harper. I say still because every time. Oh, thank you. Thank you, Sarki and Lilith. Mike D says, make me a mod. No, Mike D, you're too sketchy. We can't make you a mod. Indeed, you are not always very well behaved. Where's Reese and Dora? And also, I think that there are enough shady people who are mods here. Enough. Quite enough. Not saying these current mods, but in general, there is some shadiness in the moderation, I must say. $200 super chat to be a mod. No, I think to be a mod, Mike D needs to do something like 2,000. 2,000 and Mike D can be a mod for a month. Your cats are your kids, not actual kids. My kids are cats. My child is on my bed. $300 super chat to be a mod if you really want it. Chickpea, it's more like 2,000. It's more like 2,000. So yes, indeed, the kids here are cats, and I am just struck with the beauty of this extremely beautiful, extremely gorgeous kitty cat who is called Fujito, pineapple of my eye. Mr. Zero, 3,000 exactly. Mike D, you may want to dish out $3,000. Dry spot. Cats don't let you pet them, they scratch and bite. Okay, and we like children with boundaries. It's something I like about cats, that they have boundaries. They teach me how to have boundaries myself, even though I learn slowly. Tu es une magnifique tete de glande. Hello, Samuel. Ben Kern, who took care of your kids when you were gone? Of course I have a team, Ben. What do you mean? Of course I have a team of people. I have a team that has been interviewed, vetted, practiced, trained. Excuse you, Jay. My kitty is cuddling me and purring. Samuel, I read your comment, but I'm not exactly sure what it says, but I tried to read it. Tu as I think is you. Tu es une magnifique tete de glande. Glande. How are you? And what is the meaning of the glande? And thank you, Samuel. Who took care of your kids? Okay, I don't know what the issue is with my YouTube app that's on the iPad, but it's being incredibly slow, and I'm trying to share the live. Everybody, thank you so much for being here. Can you please like the live? Who took care of your kids? There, I've heard it on the other device, which means it's a thing that's working. So hi Fuji, hi Fuji, hi Fuji, hi Fuji. Hi Fuji. Fuji's rolling. I can't. I can't. Fuji, you're rolling, and I love you so much. Fuji, I love you so much. Steven! Hey, I'll have good news on my book. Hello, Steven. So I have seen your book pages on the stories of Instagram, but I need them to be posts in order to read them, Steven. So, Steven, congratulations on your book, first of all. And I see many pages being uploaded, but they're all a story on your Instagram. And if you want me to read the pages, then it would be better if you posted them as posts. Hi, Fuji. Fuji's over here being extremely cute. Do you give your cats catnip? Only sometimes. I don't give them catnip like all the time. I don't drug them constantly, if that's what you're asking. Thank you so much for liking the live. Please do double tap. Can we get 10 likes, please? Jaime me were dans les oreilles avec des Q-tips. Q-tips? Ça me fait tousser. What does that mean? Can anybody translate, please? Are you calling me a Q-tip? I mean, I suppose that is fine. Indeed. As long as you please do like the live, that would be most excellent. Can we get 10 likes, please? They're posted chapter 1. I thought they were posted. So, Stephen, I saw your Instagram. They're not posted. They are stories. So they will disappear tomorrow, unfortunatamente. So we need them to be posts so we can read them more permanently, okay? Baby, Fuji baby. I am sharing the live with one hand and giving pets to my favorite child with the other. So, sorry, it's a bit chaotic today. I did come back from vacation recently, so my kids need extra attention. Ariel says, what's the topic? Today we're going to talk about cosmology. Jay says, what are you, Arabic or Indian? Jay, I can tell you what I am, but you're definitely very rude. You going to be on long? Yeah, I think so. I mean, we just got started. We're going to be on for a little bit. Hi Harper. Okay. Thank you everybody for being here. Can we please get 10 likes? Hello Harper. Hello Steven. Hello Ariel. Hello everybody. Thank you so much for being here. Hello Chickpea. Are you still here? Ace Wolf Peach says why? How am I rude? Hey Jay, can you talk to Ace Wolf Peach? He'll take care of you. Ace Wolf Peach, please meet Jay with a J-E-Y and figure out his issue. Sometimes I have to delegate on this channel. I can't be getting back to everybody at the same time, especially given the diversity of comments I get here. Then I'll be back as soon as I can. Steven, okay. See you soon, Steven. Hello, Jay. Hello, Ace Wolf. Hello, everybody. Okay. So I've shared the live. And I'm gonna share it again actually, because I just want to make sure it's all good. Fuji, there's a booger on your face. Let me get it. Fuji, there's a booger on your... Oh my god, Fuji, don't. Fuji's not letting me get his booger. Okay, it's okay. So today we're gonna... Hello, Batman! Jay got the inbred aspect. We all have issues. She's selling Bibles now. What? What? What do you mean? Hello! Batman says, whistle, whistle. Batman, you better behave. Acasio59 says, hello, amiga. How's your vacations in Punta Cana? I actually went to the Puerto Rico. A port. Quite a port. So, that's where I went. She's selling Bibles now. I'm not selling Bibles. I wish. I might be better off if I were. Ace Wolf Patch Peach says Jay got the inbred aspect. We all have issues. I just got here. Wow, 30 things have changed. Doro, welcome. We're asking for 30 likes. Getting ready for our wedding, I see. Puerto Rico me encanta mucho. Puerto Rico me encanta mucho. As in, is Puerto Rico most enchanting? In that case, I agree. Entonces hablas español, says Jay. Is he on the... Okay. Okay, so we're going to read from this book, which is a little book. See, it's called A Very Short Introduction to Cosmology by Peter Coles. It's a very physically small book, so I was intrigued by it when I saw it at the library and I checked it out. I mean, I actually found it online first because I was looking up pretty much every cosmology book that I could find in the bathroom. In the library. Oh my god. Have I been saying bathroom? I meant library. Have I been saying bathroom this whole time? That I'm in the bathroom? No. I meant the library. I'm in the library. I'm going to Utah in June to sky watch. Oh, very nice. Utah is very pretty. I think I read the word bathroom. Kill Tony says Puerto Rico is a flying what? Okay. There is some Puerto Rico smells got a garbage problem. Stay away from Sky Ranch. Okay. Okay, the chat has started to do its thing. The chat here on these live streams is a beast of its own. It has a mind of its own. Thank you so much, everybody, once again for being here. I am very, very excited to say hi to everybody and to see everyone on the live in the chat and to read all your usernames. And I do hope that you will double tap the screen. Doro, did you like the live? And Batman, did you like the live? And Ace Wolf, did you like the live? So that we can get 30 likes. We're asking for 30. And Harper has already banned a few people. So if you would please behave, then I might just reach my watch time goals. With Harper in town, that may be challenging. Thank you so much for liking the live. Okay, so as I was saying, I've got this little book of cosmology. I got this from the library as well, and I do have to return it at some point soon. Now, I think that a lot of the topics in this book are basically review, and we've covered it already. But just to make sure, I thought that we will cover a little bit about the Friedmann equations from this book and comment on the parts that we've already seen or whatever we think. And let me know your comments in the chat as we keep going. And if you want to talk about something else, go for it and make friends in the chat and whatnot. Okay? The Friedmann equation can be thought of as expressing the law of conservation of energy for the universe as a whole. So that's what this guy, Peter Cole, is saying. Actually, his name is Peter Coles, C-O-L-E-S, and he's got this very little book on cosmology that we will now read from. Cosmology is the study of the universe, as opposed to cosmetology, which is the study of makeup and hair and things like that. So cosmology is the study of the cosmos or the universe, something like expansion of the universe due to dark energy, large-scale structure, cosmic microwave background radiation, Big Bang, those types of things fall under cosmology, okay? So that's what we're going to read about right now. We'll get going. We'll keep going. So the Friedmann equation can be thought of as expressing the law of conservation of energy for the universe as a whole. Energy comes in many different forms throughout nature, but only two relatively familiar forms are involved here. A moving object, such as a bullet, carries a type of energy called kinetic energy, which depends upon its mass and velocity. So if you are in sort of familiar with kinetic energy, if you took a physics class or something like that, you would know that kinetic energy, of course, depends on mass and on velocity. Something like 1/2 mv squared, if you remember an equation like that. Obviously, since the universe is expanding and all the galaxies are rushing apart, the universe contains a great deal of kinetic energy. So we know that there's expansion in the universe. We've talked about it, and how things that are far, far away are actually getting farther away because of the expansion of the universe. And so there is quite a bit of kinetic energy. The other form of energy is potential energy, which is a little more difficult to understand. Whenever an object is moving and interacting through some kind of force, it can gain or lose potential energy. So maybe you've heard of something like gravitational potential energy, or potential well, or the gravitational potential energy of a black hole or a star, or even our sun basically has a gravitational potential energy. For example, you might have heard of such a thing. So that's the other type that this author is pointing out. This is sort of the take on this topic by this author. So sometimes we read about the same thing from various authors so that we can kind of get various different perspectives, which hopefully will help with our understanding. But a lot of this is kind of like review as well, okay? For example, imagine a weight tied on the end of a dangling piece of string. This makes a simple pendulum. So everybody's seen a pendulum. If I raise the weight, it gains potential energy because I have to work against gravity to lift it. So if you raise the weight of a pendulum, of course, and then you release it, then it will begin to swing. If I then release the weight, the pendulum begins to swing, the weight then picks up kinetic energy, and as it drops, it loses potential energy. So as it's at the top, it has a lot of potential energy against gravitation, and as you drop it and it starts to move, it basically gains kinetic energy, and that potential energy is kind of converted to kinetic energy. Energy is transferred between the two types in this process, but the total energy of the system is conserved. The weight will swing to the bottom of its arc where it has no potential energy, but it will still be moving. Okay? It will in fact describe a complete cycle, returning eventually to the top of its arc, at which point it stops instantaneously before starting another swing. So it's kind of like a constant transfer of potential energy to kinetic energy to potential energy that happens in a system like this, simple pendulum. At the top, it has no kinetic energy. So for a moment when it's at the top, it's actually stopping, right? So stopping means the velocity is 0, so 1/2 mv squared is 0 because v is 0. So it has no kinetic energy at that point, and all of the energy is now potential energy at the top of the pendulum. And then as it starts to move, some of that potential energy is converted to kinetic energy, right? So this is all sort of explaining what's happening with the energy of this simple system and how it kind of transfers between kinetic and potential energy. Wherever the weight is, the energy of this system is constant. So this is a simple example in a simple pendulum system where the energy is conserved, and we kind of get it very easily because we can kind of see, we can picture it in our minds, or you can even interact with a simple pendulum to understand what we're saying, okay? This is the law of conservation of energy, okay? So, in cosmological terms, the kinetic energy depends crucially on the expansion rate, or in other words, upon the constant h naught. This is called the Hubble constant. So now remember, Hubble is the astronomer who told us about other galaxies, who actually with his observations of this universe gave us the expansion of the universe, as well as the discovery of many other galaxies and other basically these other worlds. World generally means a planet in strictly speaking in astronomy, but this whole sort of knowledge that our galaxy is one of many, and in fact if you peer into the universe, you see many other galaxies, was something that's quite new to us back about 100 years ago. We did not know that there were so many galaxies out there, okay? So that's who Hubble is. Thank you so much, by the way, for being here. Welcome to the live, and please do like the live. Please do double tap for liking the live. But this guy Hubble, of course, a very important guy in astronomy, and we have named this expansion rate called expansion rate after him, Hubble constant. The potential energy depends on the density of the universe, that is, upon how much matter there is per unit volume of the universe. So energy density of the universe is something that comes up a lot in energy density is something that comes up a lot. Hello, Ekjin22. Okay, energy density is something that comes up a lot in terms of cosmology. It is something that is often used to understand and measure different cosmic ingredients and measure sort of the makeup of the universe. By the way, we have entire episodes on cosmology where we talk about the cosmic ingredients and the cosmic makeup of the universe. So when we talk about the cosmic makeup or the cosmic inventory or the cosmic what makes up the universe, it's actually 5 main ingredients, and we've talked about this real quick. These are photons, baryons, neutrinos, dark matter, and dark energy. So just 5 types of things are there in the universe. Photons, as you know, it's light. Neutrinos is a very weakly interacting lepton particle that was discovered at some point and used to be considered a candidate for dark matter, but turns out that dark matter is probably not accounted for by neutrinos, but it is a sort of weakly interacting introverted particle that's in the same family as electrons. Baryons are ordinary matter. Most of the matter that you and me, you and I, everybody, everything is made of, most of the matter that we know and understand is baryons. These are neutrons and protons. Dark matter is the invisible matter that we find in this universe, in this galaxy. It's the extra matter that seems to be there, but we cannot see it. It does not interact with light, but it does interact with gravitation, so we call it dark matter. And turns out that most of the matter is dark matter in the universe, and then dark energy is what allows or what makes or what is responsible for the expansion of the universe. Because remember that the universe has, of course, gravitation. There's this universally felt force or phenomena of gravitation, which should be making things come closer. But in fact, the universe turns out to be expanding. Ooh, there's Baji. So what makes it expand? This is a topic of interest. It's a topic of research, and it turns out to be dark energy, and that's our fifth cosmic ingredient. Now, when we talk about energy density, these ingredients will come up, and that's why I give you a little spiel on them right here, right now. So once again, the cosmic ingredients are photons, baryons, neutrinos, dark matter, and dark energy. You know what I'm going on about because this is cosmology and we've covered it before. Come on now. J with an E. Good. Exactly. J with an E, you should probably do your homework and stop being rude to women on the internet. And mom loves you and dad loves you. Okay? I don't want to time people out because I really need the watch hours. I'm keeping my word by posting my book on Instagram one chapter at a time. So Stephen, I was telling Stephen Doro that his book is actually stories right now instead of posts, and I think by mistake he posted the book as stories rather than posts, okay? What? So the sun cooks the ingredients. So the sun actually cooks hydrogen to make helium. So the sun burns hydrogen. It does nuclear fusion of hydrogen to make helium. That's what the sun does. So what the sun does is sort of a subset of what all of this is. The sun is astronomy. So remember, we're talking about cosmology now, which is sort of a much more large scale topic. It's the topic of the universe. So there's the universe and what are the 5 ingredients of the universe, which is really a very basic and very like foundational way of talking about the universe. It misses a lot of the details, right? So when you talk about the sun is really a detail in the universe. It's a very detailed little specific thing when it comes to the entire universe, right? We're talking about the universe as in when galaxies weren't like the evolution of the universe comes, starts from the Big Bang to now, and at one point there were no galaxies, there were no stars, there was no sun, things like that. So I would say that what the sun does is kind of falls under astronomy and nuclear physics and nuclear astrophysics and astrophysics. So yes, it burns hydrogen and it utilizes hydrogen to make helium, and that's basically the nuclear power plant in the belly of the sun, which makes the sun burn and the sun glow and the sun give us light and energy and heat and all that. But it doesn't necessarily involve all of the ingredients of the universe. Although I will say, good point, it does involve neutrinos. So neutrinos is it's a particle that is generally emitted in every nuclear reaction. So it's very commonly made in a lot of nuclear physics types of interactions. Like pretty much no matter what you do, you end up making a neutrino. So actually, the sun involves 3 of the 5 ingredients. So you're not far off. The sun involves photons, obviously light, baryons, of course, because it involves neutrons and protons, and it does involve neutrinos. So those are 3 of the 5 ingredients of the universe. So in that sense, not far off. But the universe as a whole, turns out, involves a lot of dark matter, which we didn't think it would, but it does. And it also involves dark energy, and it involves dark matter and dark energy mostly. Turns out ordinary matter is only like 5%, and everything else is dark matter or dark energy. Okay, so with that little spiel about the cosmic ingredients, we'll go back to understanding what the energy density of the universe is. So this is going to be a little bit different than what you might be thinking, so just kind of stay tuned here. So in cosmological terms, the kinetic energies, we just looked at the simple pendulum example of where the energy was being conserved between potential energy and kinetic energy. At the top of the pendulum, the energy is all potential energy and the kinetic energy is 0, but as it starts to move, some of that potential energy is converted to kinetic energy, and the total energy of that system in that simple pendulum system is always conserved. In other words, the same sort of thing is expected in the universe. So let's see what he has to talk about in terms of energy density here. So the potential energy depends on the density of the universe, that is, upon how much matter there is per unit volume of the universe. Unfortunately, this quantity is not known at all accurately. It is even less certain than the value of the Hubble constant. If we knew the mean density of the matter and the value of h naught, which is the Hubble constant, however, we could calculate the total energy of the universe. This would have to be constant in time in accordance with the law of conservation of energy, or in this context, the Friedmann equation. Fusion, not fission. What do you mean? Heike and Noindri has seen it. Yes. Yes, your book is in your stories. Where were you with that beautiful dress? Which one? Fusion. So you're correct that the sun is doing fusion. Fission is what the atomic bomb is. Human beings figured that one out, but the sun mainly does fusion. Correct. If that's what you're asking about. Okay. So if we knew the mean density of matter and the value of h naught, however, we could calculate the total energy of the universe. This would have to be constant in time in accordance with the law of conservation of energy, or in this context, the Friedmann equation. Setting aside the technical difficulties that arise when general relativity is involved, we can now discuss the evolution of the universe in broad terms using familiar examples from high school physics. So he's kind of relying on some analogies here, I think, going forward in sort of explaining what goes on with this universe math. But it's not going to be exact because the universe, of course, involves general relativity, which has some complicated equations. So he's kind of bypassing that and giving you sort of an analogous type of example, okay, to explain things. Thank you so much for being here in the live. Can you please double tap and like the live? For instance, consider the problem of launching a vehicle from Earth into space. Here, the mass responsible for the gravitational potential energy of the vehicle is the Earth. The kinetic energy of the vehicle is determined by the power of the rocket we use. Because, of course, when a rocket is being launched from the Earth, the gravitation that it has to surpass is the gravitation of the Earth. And the Earth has a gravitational potential energy that it has to kind of escape, right? And we give the rocket fuel so that it can have kinetic energy. So whenever something moves, it has kinetic energy. And if it is kind of overcoming the gravitational potential energy to have that kinetic energy, that's what this is kind of talking about. So if we give the vehicle only a modest rocket so that it doesn't move very quickly at launch, then the kinetic energy is small and maybe insufficient for the rocket to escape from the attraction of the Earth. Consequently, the vehicle goes up some way and then comes back down again. In terms of energy, what happens is that the rocket uses up its kinetic energy given expensively at launch. to pay the price in terms of potential energy for its increased height. If we use a bigger rocket, it would go higher before crashing down to the ground. Eventually, we will find a rocket big enough to supply the vehicle with enough energy for it to buy its way completely out of the gravitational field of the Earth. So by the way, guys, does anybody know the escape velocity from the Earth? So if you go a certain high velocity, then you can actually escape and kind of get into orbit around the Earth. But you would have to have enough kinetic energy to kind of not be trapped back and fall to the floor or fall to the ground again on Earth, okay? Eventually, we will find a rocket big enough to supply the vehicle with enough energy for it to buy its way completely out of the gravitational field of the Earth. So this is the analogy that we're going to be using. The critical launch velocity here is usually called escape velocity. Above the escape velocity, the rocket keeps on going forever. Below it, the rocket comes crashing down again. So this is what I was just talking about, and he kind of said it himself, which is that, of course, if you want to escape the Earth, you would have to be going at an escape velocity, and if you want to come crashing down, then you can go at below that escape velocity, and you will fall back down to the Earth. But if you go above that, then you will actually escape. In the cosmological setting, the picture is similar, but the critical quantity is not the velocity of the rocket, which is analogous to the Hubble constant and is therefore known, at least in principle, but the mass of the Earth, or in the cosmological case, the density of matter. So this rocket business that we just talked about, the rocket, the Earth, the gravitational potential energy of the Earth, and the kinetic energy of the rocket, all of this is sort of an analogy of what we're about to talk about with the universe and whatnot. This is just Peter Coles' way of explaining to you what some of this is with the universe. So just hang in there, hold tight. So in the cosmological setting, the picture is similar, but the critical quantity is not the velocity of the rocket, which is analogous to the Hubble constant and is therefore known, at least in principle, but the mass of the Earth, or in the cosmological case, the density of matter. So the density of matter is going to be important. It is therefore most useful to think about a critical density of matter rather than a critical velocity. If the real density of matter exceeds the critical density, then the universe will eventually recollapse. So this is sort of getting to that point of expansion versus recollapse versus not expansion too fast versus expansion too fast, things like that. We've kind of actually looked at an example of this. Remember those curves I showed you a while ago? They're in my shorts as well, and somebody's been recommending that I turn the camera or something because things have come up inverted because of the camera being whatever. But I'm about to show this to you again, probably inverted again, but I think you'll get the idea, which is that basically if the real density of matter exceeds the critical density, then the universe will eventually recollapse. So if the expansion of the universe is slow, then it will recollapse. If it's very fast, it will never recollapse. And if it is sort of a critical rate, then it will do some currently known type of expansion. So we will see, right? So again, if the real density of matter exceeds the critical density, then the universe will eventually recollapse. Its gravitational energy is sufficient to slow down, stop, and then reverse the expansion. So recollapse would mean that there has been expansion, but it would slow down, stop, and then reverse the expansion, meaning it would collapse upon itself. And this is exactly, by the way, what people asked about when Einstein was doing his general relativity equations for the universe, and he was asked to consider, well, if the universe has gravitation, and gravitation is always an attractive force, it's always attractive, it's universal, everything feels it, and it's always attractive, it's never repulsive. So why is the universe sort of steady? Why doesn't it collapse upon itself? And so he had to introduce the cosmological constant to kind of give his equations this constant to keep the universe static against gravity, an anti-gravity term. But turns out that not only is the universe not static, it's actually expanding, which begs the question, what kind of expansion rate do we have? Because if something is expanding slow enough, then it could be that sort of like that rocket, it could be that it expands, the expansion slows down, then stops, and then reverses, which would be a recollapse. Yes, of course. Yes, they're generally exoatmospheric. ICBMs, of course, ICBMs are generally exoatmosphere. They absolutely go out of the atmosphere first. I'm not talking about ICBMs right now in the Steven, did you become a member? Oh my gosh, thank you so much. I think you're my first member. Welcome. I'll make content just for you. I'll have to make member specific content. I'm getting there, but thank you so much for becoming a member. Wow. Just letting you know, I have put my little white friends in storage. What? What do you mean? I thought it was Harper banning everyone. So Grimmy, I'm talking about cosmology, but this guy whose book we're reading, called Peter Coles, who has written a very tiny book on cosmology that I got from the library, he is using the analogy of rockets and potential energy and kinetic energy to kind of explain what happens in the universe with its expansion. Okay? That's what's going on. She is or he is a plock. What? You're dressed nice. You have a good... Am I dressed nice? Oh, thank you. Oh, yeah. I guess so. I guess this is a nice enough dress. Thank you very much. I did not... Oh, I guess I went out, but that was just for a walk. I went out for a walk. Her membership is called Become a Member. What do you expect, man? My membership is called Become a Member. In fact, I should rename it Become Like Steven. I'll rename it after this. I'll rename the membership Become Just Like Steven. Those pearls look nice. Thank you. They are pearls. One of my best friends gave me these pearls, actually, for my, actually, these might be from my wedding. Many, many suns and moons ago. See, that is actually good. Good, what is good? Splitting atoms is fission. Fusion is when, exactly, good. So the atomic bomb, I was going to say atom. Atomic bomb is an example of nuclear fission where a larger nuclei is being split, and then, hello, a kitty cat is over here, and some of the split parts are going in and splitting more atoms. Fusion is when two nuclei come together and make a new element. For example, hydrogen being used to make helium. Become like Steven, he's the GOAT. Thank you, Steven, for becoming a member. Good luck with that, you're already promised. Promised with what? A GOAT who is an amateur. It's Sachi Mama. Oh, Suji went over there. Wow, Steven, you're my first member. Oh my gosh. Steven, I will make more member-specific content just for you and just for me. And, okay. I think I got everybody for the most part. Thank you so much, everybody, for being here. And please do like the live. Can we get 20 likes? Can we get 30 likes? And Steven, if you could, please repost your book as like posts on Instagram. instead of the stories. I don't know if you already talked about this or not in the comments. Then I can actually read your book easier by looking at the posts instead of the stories, okay? What do you mean is well, what do you mean promise to someone? I think it's something like 11 kilometers per second, right? Which in a different unit might be something else. Yeah, that's okay. I think, Steven, it's totally fine. No rush. I just wanted to point out, and I also messaged you on Instagram. I don't know if you saw my messages, but no rush. There is really no rush or urgency. There is really no rush or urgency. I will get to your book in the next couple days as soon as they become posts, and do your thing until then. Raikudo, hello. I know, I am in Steven's DMs. Usually people are in mine, but I am in his. Indeed, I am in his. I'm looking at Steven's like 10,000 freaking stories, and I'm like, Steven, these are stories. Can you put them as posts? But Steven, no worries. Just forget it tonight. Just enjoy the live and then go to bed and don't worry about it tonight, okay? We will read it on Monday. How about that? We will read it on Monday or Tuesday, okay? Steven is a boomer, but we love him. She's in his DMs. I thought marriage was arranged at birth. Hello, looking exquisite. Oh, hello, completely insane. How are you? Hello. Hello, insane. How are you doing tonight? Thank you so much for being here. Can you please like the live? Steven, don't do it now. Oh, you're the only one who listens. Can you do it later? Can you do it in the morning? Don't do it now. Do it in the morning. Can you please like the live? Double tap to like the live, please. Thank you. So the marriage question. My marriage was not my former marriage. I'm currently not married. In the past, my darling. In the past, this marriage was not arranged. Not every Indian has an arranged marriage, if you didn't know. But I end up doing something else. Yes. Can we get 30 likes, please? Now we ask for 30. We're increasing like we increase the weights that we lift. 20 pounds one day, 25 the other, 30 pounds the next day. I'm doing just fine, chilling like a villain. Chilling like a villain. So somebody was asking about marriage. Are you quite done? My marriage is. So, are you done asking about it? Oh, I'm just married to Kamala Harris. So at my former wedding, I received these earrings from a friend. You're not married, wow. Would you ever get married again? Depends who's asking. That was fairly clear to me. A lot of Indian men hit on the streamer I mod for. What? Coco Vita. She ruined greatness. Who? What are you talking about, Dora? Alright, we'll keep going. So, Setting aside the technical difficulties that arise when general relativity is involved, we can now discuss the evolution of the universe in broad terms. Okay, we saw this already. In the cosmological setting, the picture is similar, but the critical quantity is not the velocity of the rocket, which is analogous to the Hubble constant. Can we get 20 likes? Aww. Oh, I'm so sorry. I did not know it was your first member. Of course you are, Steven. You're the good boy here. Look at everybody else. Bad, bad boys. Bad. Very bad. You're the good student. Sachi? What's wrong, Sachi? Sachi's feeling extremely ignored. Just like old times. It won't be me, you had to be the first. Andrew's rich. Dora, stop spreading misinformation. Did you know that my property tax has increased? And that I cannot afford anything anymore? Nothing. I'm drinking Coco Vita. I can't even afford the chickpeas now. Actually, no, I can, because the chickpeas are cheaper than Coco Vita. Coco Vita, please feel free to send more. And then I will say that this live is sponsored by Coco Vita, which currently is not. I'm not bad. Aww, you're not. Chickpea, you're the best mod. You're doing so good, thank you. Eat meat. Goodness. I should show you this one video I made while eating meat from a Brazilian restaurant the other day. Well, a Brazilian takeout restaurant, because I can't afford the sit-down ones. So I got Brazilian food, and there was meat in it, and I was chewing and chewing and chewing and chewing and chewing and chewing. Now, why did I do this? Because I am supposed to eat protein, because my friend, who is a man, has been lifting less than me, but his muscles have been growing more than mine, and he's been getting harder and harder. And I was like, wait, what are you doing? And it's because he's eating more protein than me. So I was like, okay, fine, I'll eat meat once in a while. But it's a lot to chew. It takes forever to chew. I so much more appreciate and prefer vegetables. Head on the streets for some fresh coconut water. Exactly. Can we get a super chat? His muscles. Oh gosh. His arms. Can we get a super chat of $500,000, please? Thank you so much. So, we will now talk about if the real density of matter exceeds the critical density, then the universe will eventually recollapse. Its gravitational energy is sufficient to slow down, stop, and then reverse the expansion. If the density is lower than this critical value, the universe will carry on expanding forever. The critical density turns out to be extremely small. It also depends on H0, or the Hubble rate, but is on the order of 1 hydrogen atom per cubic meter. Wow. 1 hydrogen atom per cubic meter. Most modern experimental physicists would consider material with such a low density to be a very good example of a vacuum. So 1 hydrogen atom per cubic meter. So a cubic meter is the volume. So a meter times a meter times a meter is the volume. So a meter length on each side of a cube, that's the volume. And then if you had 1 hydrogen atom in it, that would be the critical density. So this critical density is rather small. So if, depending on who you're asking, oh, there's Baji. Depending on who you're asking, they might just call this a vacuum, but of course there's like 1 hydrogen atom, I suppose, So that's the critical density, quite low. Yes, I prefer chickpeas. That's my preferred method of intake of protein. Donate some money. Very true. Okay, so and now at last we can introduce the quantity omega. This is simply the ratio. Wait, I think that's an omega. I'm looking at the symbol and I'm like, wait a minute, what the frick is that? That's big omega. So there is the omega as in the small little omega, which is a W looking thing. Oh my goodness, Fuji. Oh my goodness, you're so cute. Oh my goodness, you're the best. There is the omega symbol, which is the little omega, which looks like a W. Then there is the big omega, which looks like this. Let me write it. Where's my pen? I don't have my pen right now. It looks like this. Whatever, doesn't matter. So, we can introduce this quantity omega. It is simply the ratio of the actual density of matter in the universe to the critical value that marks the dividing line between eternal expansion and ultimate recollapse. Okay? So like eternally expanding would mean that the expansion rate is very high. It is so high that it's just like avoiding recollapse. Like there's not even a question of recollapse. It's just going to keep on expanding and expanding and expanding. We mean the universe. And then recollapse means that the expansion rate is not so high, so it will recollapse. As soon as I post, I'll let you know. Thank you. I needed to get Adam by Dr. Krauss. That's very true. Dr. Krauss, please do send a copy of your book. Will you show your tongue? Don't ban him. Can you guys please behave so that my mods don't ban you and I get my watch hours? Like a horseshoe. Yes! Right, Kudo? Love it. Right, Kudo is basically saying that the big omega looks like a horseshoe. Acacio! Oh my goodness, let me love that. Super chat. Acacio has done a super chat. Goodness gracious me. Wow. Wow, wow, wow. Acacio 59. Muchas gracias. Wait, did I say that right? Muchas gracias. Thank you so much. Thank you so much, Acacio. Thank you for doing the super chat. Wait, now I can't see. Now I can't do anything. Oh, there we go. There we go. Thank you so much. I was trying to like the chat. Hopefully I did that. Dark Gloom. Hello. So yeah, the omega looks like a horseshoe. So Raikudo is correct. Mr. Benjamin, you're a dashing fellow. How about you stop being that way and listen to her? Hello, Benjamin. That's right. Thank you so much. Dark Gloom says hello, hello. Hello, Dark Gloom. Hello, Chickpea. Just bent outwards at the end. Yes, exactly. Super chat, we're getting an Atom by Dr. Krauss after her property tax. Exactly. The property tax has almost doubled at this place, which makes it very difficult for me indeed. Everybody, if you would like to help pay the property tax, that would be most appreciated, and Acacio already has. Look at that. Look at this property tax help that I'm getting, which thank you so much. Thank you so much. That's correct. Gracias, and I say de nada. Oh, thank you. Gracias. Thank you, thank you, thank you, thank you, thank you. De nada. Welcome. Very nice. So, now that we know what omega is, it looks like that horseshoe thing that Raikudo is talking about. Basically, we got eternal expansion if omega is very high, or the expansion rate. I mean, you could pick a different symbol for expansion rate. This guy is using omega. Some people actually use lambda, I believe, but if this expansion rate is very, very high, then you will just have expansion forever, forever, forever. If the expansion rate is lower, then you would have a recollapse type of energy. Okay. She's a Richie. Not anymore, I used to be. She got a super chat. Thank you. You should donate. Mr. Casio, thanks so much. Thank you. Hi, Grimmy. Things are so expensive now. I'm not really that rich anymore. Benjamin Robe, do you want to do a $600 super chat, or $600 for you to not get banned, and $4,000 for you to be back tomorrow? Thank you, Casio. So one of these omega cases, or the expansion rate cases, basically will coincide, will basically apply to the flat case, where the universe is avoiding recollapse, but its expansion is not so strong either. It's not so quick either. And the other case is where the expansion rate is a bit lower than the flat case, and we expect there to be a recollapse. And then the third case is where the expansion rate is pretty high, as in it's above the flat case, and we will pretty much eternally expand. Aw, Benjamin is gone. She's a businesswoman. I see. He wasn't gonna pay. Why is he? I know. What was his name again? Benjamin. Benjamin, if you want to come back to the chat, just do a super chat. Do a $50 super chat to be let in again. Chickpea break, you're so cringe. Why? What's Chickpea done? Chickpea is so helpful with the super chats. Grimmy told me you were attacking people for super chat. That's funny. So here's the thing that's inverted again. These are the three cases of these curves. See how the top one if omega is greater than 1, then the expansion will eventually stop and the universe will recollapse. If it is less than 1, the universe will expand forever. Poised between these is the flat universe with omega finely tuned to be exactly unity. We're gonna get more super chats by being extra polite. Yay, thank you. I can't with this guy, no way. Okay, so then the long-term viability of the cosmological expansion is not the only issue whose resolution depends on omega. So the long-term viability of the cosmological expansion What is so funny, Grimmy? Why are you being mean to my friend Chickpea? Thank you for the hearts. Can we get 20 likes? Can we get 30 likes? Can we get 40 likes? Thank you so much. So, as we can see, and to reiterate and kind of summarize, depending on the expansion rate, you will either have a flat universe, you will either have an eternally expanding universe because the expansion rate is too high, or you will have a recollapsing universe because the expansion rate is not high enough. And to explain all of this, he gave the example of the rocket that's launching from the Earth, and depending on the escape velocity, it will either come back down and hit the ground because it could not escape the gravitational potential energy of the Earth, or its kinetic energy is fast enough where it kind of keeps going forever, or it is basically sort of at that critical level. Okay, so what else does this expansion rate mean? So these arguments based on simple ideas of energy resulting from Newtonian physics are not the whole story. In Einstein's general theory of relativity, the total energy density of material determines the global curvature of space. So this energy density stuff that we just talked about has more meaning in general relativity, in the sense of a space-time curvature. Because remember that in general relativity, space-time is curved, and gravitation is sort of this fabric of the curvature of space-time. And so all this energy density, matter density stuff that we're talking about has more meaning in terms of what actually it implies in general theory of relativity. Okay, so these arguments based, so once again, even though he used the analogies of the Newtonian physics with potential energy, kinetic energy, the rocket example, to kind of understand, to kind of help you understand what we mean by the expansion rate, actually, what we're kind of talking about here with the energy density of the universe has deeper meaning when it comes to general theory of relativity. So in Einstein's general theory of relativity, the total energy density of material determines the global curvature of space. A space of negative global curvature results in models with omega less than 1. A model with negative curvature is called an open universe model. And open universe model means expansion rate is too high. It's higher than the critical rate. A positively curved or closed model pertains if omega exceeds unity. This is where the universe will recollapse, right? And so remember or note that there are different models in cosmology that allow for different sort of fates of the universe. So depending on if you want the universe to collapse upon itself at some point, or if you want the universe to be open as in expands forever, or if you want the universe to be flat as in the expansion rate is sort of at the critical rate, you can have sort of a different cosmological model that allows for each case. And then what you can do is, yes, Fuji, you can do the math for each of the cases, and then you can see with experiment, you can verify which case is the one that is sort of matching your experimental observations the best. And actually, this is kind of how people do the cosmological stuff, is because they, in the beginning, they can only have these models. They don't necessarily know all the different parts of their equation and all the numbers that can go into the equation. So they come up with the models and they use these different values of the omega, for example, the expansion rate like we are talking about here. And depending on that expansion rate, you will get a different model of the universe. And then depending on which model, after everything is fitted, actually matches your observation the best, you will know whether the universe is closed, whether it's open, whether it's flat, okay? So hopefully that makes sense. Good night, Grimmy. Hi, Adam. Hello, Adam. Who is purple? So, thank you for being here, Adam. Thank you so much. Welcome to the live. Welcome, welcome. And can we get 20 likes, please? Can you please like the live? Brian? Who is Brian? Um, I called you Brian. What? Called me Brian? I was trying to look for the... Makes sense that it will collapse into a single black hole. So I don't know if it will collapse into a single black hole. It may, like the Big Crunch, if it were to collapse, that could happen. It could collapse back into a singularity. Right now, it's interesting that you mentioned the black hole, because that is the other singularity that we know of. The Big Bang, which is where the universe is thought to come from, was a singularity, as well as a black hole is an example of a singularity. Hi Fuji! Fuji siya na mama's working siya na? Fuji, mama loves you! Fuji's throwing a tantrum. Okay, so I wanted to mention that cosmology oftentimes is done with these models. You don't always know every single part of your equation, because you're talking about the entire universe here. So sometimes you plug and chug some of the equations and some of the symbols or variables, and you kind of play with it. Basically, you could play with the possibility that the universe is open or closed or flat. And as it turns out, that after doing these models, thank you so much for the hearts. Can we get 20 likes? As it turns out with these models, what is actually seen and matches the observation the best is the flat model. So we didn't just say that the universe is flat like it's our hobby, or we wanted to. That is actually the model of the universe. After we came up with these cosmological models of the flat, the open, or the closed universe, after we came up with these cosmological models, we actually saw that the flat one matches what we observe the best. And we talked about this in a previous live when we talk about cosmology and cosmological models and dark energy and expansion of the universe. We talked about this. So the universe being flat, meaning the expansion rate is equal to the critical rate, which keeps the universe flat, as in it's not open, it's not closed, it's flat. That is the universe that we observe, okay? So once again, a space of negative global curvature results in models with omega less than 1. A model with negative curvature is called an open universe model. A positively curved closed model pertains if omega exceeds unity. So that same symbol, if it's more than 1, then it would be exceeding unity. In between, there is the classic British compromise universe, poised between eternal expansion and eventual recollapse, which has omega exactly equal to unity. This model also has a flat geometry in which Euclid's theorems all apply. What a relief it would be if the universe chose this simplest of all options. I got my own place and I own everything. Very nice. I don't. I own my land and I built my house. Look at that, chickpea. Chickpea break. Dang, I wish. I bought mine. I pay a freaking mortgage. Good job, chickpea break. Which is why I question how much mass would it take where the force of expansion would overtake the gravity the mass generates, like those supply and demand charts. So as far as I know, that's already happening, right, Kudo? The expansion is more the expansion is happening in the universe. So it is an anti-gravity term that's winning. I abuse the banking system. What? I only use the bank to save. Thank you for the hearts. MSTR Ronan says hi. Hello, MSTR. Are you in astrophysics, ma'am? Hello, Adam. Yes, I did my what am I even saying? I did my PhD in physics with a subfield of particle astrophysics and a bit of cosmology. So yes, I did physics. My degrees are in physics, and physics, and the focus was in particle astro. Okay. Where is this other comment that I just read? Something about. We will talk. By the way, right, Kudo? We will talk more about the comment you made. I'm reading the comments. Chickpea break. With all the money you can give super chats. Go on, best mod. That's true, Chickpea break. We were not aware that you're so rich. Why don't you give us $500,000 that you're saving from the mortgage? Can you tie ponytail hair, please? Hello, MSTR Ronan. Can you give us $500,000, please? Your face is beautiful. This was more for figuring out how to break a supermassive black hole. Don't walk it back now, Chickpea. Give some money, rich man. Building a house isn't easy. That's true. Hello, Doro. Hi. I'm not rich. Donate some money, rich man. $20 super chat? No! What do you mean? A super chat for ponytail, we asked for $1,000, Chickpea. Are you serious? I don't even have a ponytail hairband right now. I have to make one, and for that I need $1,000. Coco Vita costs $20. Please, 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 please. $100. 100. Cheaping me out. $100. 100. You look like you work at a 7-Eleven, and so what I do? Chickpea break, give us some super chats. Isn't that how you said it? Donate money to us. $1,000 super chat for a case of Coco Vita and ponytail. Okay. Okay. The quantity omega determines both the geometry of space on cosmological scales and the eventual fate of the universe. So of course it gives us geometry, geometry that we don't always know exactly what it is of the universe, because the universe is very big and we can't see every part of it. So part of this expansion rate geometry, expansion rate thing is about geometry, and partly it's about the fate of the universe, like understanding sort of what will happen to this universe is part of it as well. We did land on the moon. Steven is correct. Gosh. Gosh, oh gosh. Gosh, oh gosh. Gosh, oh gosh. Okay, so it's important to stress that the value of omega is not at all predicted in the standard Big Bang model. It may seem to be a fairly useless kind of theory that is incapable of answering the basic questions that revolve around omega. But in fact, that is an unfair criticism. As I've explained, the Big Bang is a model rather than a theory. As a model, it is self-consistent mathematically and compared to observations, but it is not complete In this context, this means that omega is a free parameter in much the same way as the Hubble constant h naught. To put it another way, the mathematical equations of the Big Bang Theory describe the evolution of the universe, but in order to calculate a specific example, we need to supply a set of initial conditions to act as a starting point. Since the mathematics on which the model is based break down at the very beginning, so we have no way of fixing the initial conditions theoretically. So this is because the Big Bang is a singularity. So by definition, mathematics will break at the singularity. The Friedmann equation is well defined, whatever the values of omega and h naught, but our universe happens to have been set up with one particular numerical combination of these quantities. All we can do, therefore, is to use observational data to make inferences about the cosmological parameters. Exactly. So we know something about these equations, as in we know what the equation looks like with these variables, but we don't always know the values of everything. We set it up, plug and chug. We set it up with these different assumptions of like what the model is, because we can assume whatever we want. We can play with whatever model, we can assume whatever model we want, and then we infer with observation which one is matching the best, okay? Nathan, hello. Hello. Excuse me. So once again, the Friedmann equation is well defined, whatever the values of omega and h naught, but our universe happens to have been set up with one particular numerical combination of these quantities. All we can do, therefore, is to use observational data to make inferences about the cosmological parameters. They cannot, at least with the knowledge presently available and within the framework of the standard Big Bang, be deduced by reason alone. Like, you can't just reason everything about this universe and everything about the cosmological parameters. Some of it is you set it up as the equations and then you plug and chug the different models and you see which one kind of matches your observations the best, okay? On the other hand, there is the opportunity to use present day cosmological observations to learn about the very early universe, okay? You're actually crazy. I can see your craziness, says Jay. Do explain, Jay. You can't just call a person crazy. What kind of crazy are we talking? Give us a little bit of a psychological explanation of your commentary here, my darling. Chickpea says, and that doesn't count for sheet. I'll make it happen soon enough. I actually don't have a PayPal or a credit card. I have a private banking card. Oh, that's cool. That's cool that you don't have a card, like a credit card. That's great. Can't even buy stuff online. You don't have a credit card? Dang, man, they're awesome. Thank you, everybody. Thank you, Doro. Thank you, Chickpea. Thank you, Steven. Thank you, Nathan. Nathan, how are you? I told the universe to give lots of money. It became true. Hi, Adam. Something tells me you're fibbing. An attractive crazy. Oh, goodness. Jay, I'm probably your mother's age. Do have some respect. You're probably 16 or 13. Or are you in 7th grade, Jay? Tell us. Isn't it your bedtime? 12:51 in the morning. Watches a tumbleweed roll across the floor. Listens to the crickets sing. I'm 50. It's true. 50. I'm good, got a second job, so working nights at Tractor Supply now. Nathan, what happened to your 9 o'clock bedtime? Maybe 20s by today's standards. What, my age? My age used to start with a 2. I'm 35. Oh gosh. Doro, there is somebody your age here. It's Saturday. Oh, Nathan, are you working on Saturday at the tractor place? And you're gonna be not going to bed at 9 p.m. on Sat and Sun, is that right? I do like this dress. It is blue. I like it. Oh gosh, your gravity is like a blue supergiant. Thank you, my darling. Jay's age. Oh God. I know your age. I'm 29 again this year. Jay isn't lying. Every other weekend. So Nathan, what is your new bedtime, my dear? I wish I looked as nice as... I know the live is free unless you're Jay and about to donate $500,000. All of y'all who are attending the live instead of going outside, you're doing great. You're saving money. You're not paying tips. You're not getting drinks and food and other things outside, which means you're saving money, being home, coming to the live, and donating to the live all your spare change of $500,000 and to a good cause. So thank you so much. And good job, everybody. Support her cosmic research with a small donation. Thank you, Adam. Thank you. I did all that before the live. Doro, excusez-moi, how dare you eat and drink and be merry with your architecture money? Right? Architect? It's 1 a.m, not much to do outside. Don't say Thank you, everybody. Thank you so much for being in the live, and thank you for doing a super chat. Ocasio, thank you so much. Mike D, thank you. Mike D says hi. I'm in architectural work. Yes, so is Grimme. What's up, little head? Hello, the bears. You think I'm a simp sending money? Oh, Adam! Oh my gosh! Adam sent money. Wow! I can't believe it. Oh my God, it's Canadian. Oh my God, Adam, are you Canadian? Oh my gosh. Oh, I feel so bad. As in, I don't feel bad. I just... Are we harassing a Canadian? Oh, I'm so sorry. Canadians are so nice. Wait, why does it say that I have $26 now? Oh my God, YouTube. YouTube is converting all the Canadian dollars to USD. What the frick? No, Canadians are the best. Adam, thank you so very much. Adam, right? Yes, Adam Dolson. You are a doll. Let me like that super chat. It's orange. How come the colors are all changing? I didn't even know that that was a thing. Thank you so much, and thank you so much for the hearts, everybody. Adam did a 20 Canadian dollars super chat. It even says CA. Wow. Welcome, Canada. Welcome, our friendly neighbor. You look nice tonight, B. Thank you. Adam did it. Adam did it. Adam, you've done it. You're the man, Adam. Wow. Canadian too. Canadian. Learn something. Learn something from this Canadian US Learn something. Learn something. Look at how nice he is. He has not misbehaved once. Everybody who comes to the class usually misbehaves most of the time, except for some nice people. Adam, the same. Oh, shut up, Jay. Shut up. He put his money where his mouth is. Aw, thank you, Adam. I love Canadian bacon. Canadian bacon, bacon, not bacon. Bacon is kind of like ham, right? It's like I think it's like the bacon that's in an English breakfast, full English breakfast. Is that right? Canadians can get rough ornery. Yes, ma'am. Aww. Thank you, Adam. Thank you so much. I used to work for Walmart and worked. Oh my gosh. Bret Hart, #1 Canadian wrestler. Some are. I know personally not all. What? Not all nice? I think Canadians are generally nice to me. Stop it. Be nice to our Canadian guest. Beckham. Beckham. Bend it like Beckham. Jay, your troll game is weak. They're laughing you off. Best to give up. Russians are nice also. Mike D, are you Russian? Is that what this is? Are you Russian? Is that why you're so direct and rude? Is this what this is? You know, the Russians have an Antarctic base called Vostok. And it's a very dangerous place indeed. Indians are known for being direct and rude. Maybe Indian men. Not me, I'm so sweet. Thank you for liking the live. Can we get 20 likes? Are you from the 11th province? Wow. Adam, Jay, look at you guys. Look at you guys. Thank you so much once again, Adam. Thank you so very much. You're incredibly kind and helpful. Okay, let's keep going for a bit. So the search for two numbers. 30 likes. Well, I wanted to get to 20 likes first before it gets to 30. Can we get 20 likes first, and then can we get 30 likes? I worked for a Canadian company. Those ones did not like Americans, and they were fairly obvious about it. They only treated me slightly better because I was native. Oh. Welcome Native America and Native Canadians as well. Welcome, welcome. Thank you so much for being here. I appreciate the lives about these topics. My pleasure. Good to think about the nature of the cosmos. You are in the right place, my dear. Adam, you're in the right place. I live in the state of insanity. Okay, so the importance of determining the cosmological parameters was recognized early on in the history of cosmology. Okay, so even though getting the cosmological parameters is not necessarily a trivial matter, because it's difficult for us to measure these things or know what they exactly are, and sometimes all you can do is come up with these models and then, as I was saying, kind of plug and chug and see what fits best with observations. Indeed, the distinguished astronomer Alan Sandage, however you said that name, Alan is A-L-L-A-N, Sandage is S-A-N-D-A-G-E, formerly Hubble's research student, okay, that makes sense, once wrote a paper entitled Cosmology, the search for two numbers. Two numbers. Let's see what these numbers are. 2 decades later, we still don't know the two numbers, and to understand why, we have to understand the different kinds of observation that can inform us about omega. So the two numbers I believe are omega and the Hubble rate. And let me also real quick check which year this was published in, because some of this might be a little bit old. I think this is, oh, I see. This is from 2001, this book. So actually it's a little old, and some of this might be a little bit outdated, okay? But it's okay, we will still hear from a different perspective than some of the other authors and go from there. Be nice to our Canadian guest and double tap the screen. Can we get 20 likes? Okay, so 2 decades later, as in 2001, we still don't know the two numbers, and to understand why, we have to understand the different kinds of observation that can inform us about omega, which is the expansion rate, and what kinds of results they have produced. There are many different types of observations, but they can be grouped into 4 main categories, okay? First, there are classical cosmological tests. The idea with these tests is to use observations of very distant objects to measure the curvature of space, or the rate at which the expansion of the universe is decelerating. So the rate at which the expansion of the universe is decelerating or slowing down. So, the simplest of these tests involves the comparison of the ages of astronomical objects, particularly stars in globular cluster systems. With the age predicted by cosmological theory. I discussed this in chapter 4, so we haven't seen him discuss it yet, but because if the expansion of the universe were not decelerating, the predicted age depends much more sensitively on the Hubble constant than it does on omega. So certain different interesting implications come from the different sort of what something means. So basically, if the expansion of the universe were not decelerating, that has certain implications, such as the predicted age will depend more sensitively on the Hubble constant, or h naught, than it does on the expansion rate. That's just a detail or some fun fact about all this. And in any case, the ages of old stars are not known with any great confidence. So this test is not a powerful diagnostic of omega at the moment. So sometimes, they use certain observations that are itself a little bit questionable, such as the ages of these very old stars, like what this author is talking about. Like sometimes, like understanding those ages itself is a challenge, and maybe they can be sort of a reference, but how accurately they tell us anything is also sort of questionable, okay? So let's see, other classical tests involve using the properties of very distant sources to probe directly the rate of deceleration or the spatial geometry of the universe. Some of these techniques were pioneered by Hubble and developed into an art form by Sandage. They fell into some disrepute in the 1960s and 1970s because it was then realized that not only was the universe at large expanding, but objects within it were evolving rapidly. Steven, you can do it next week. No rush. Do it like Monday or Tuesday and we will read it then, okay? There is no rush, Steven. Because I think tomorrow we'll talk about more cosmology, and then Monday or Tuesday we can read your book. What? I'm encouraging him to rest. And sometimes that encourages people to do more work. He's an American. If I tell him to rest, he'll probably work more. He's not French. This book is called Cosmology, A Very Short Introduction. See how this is a very tiny little book from the library. I got it from the Malden Public Library, actually. Or actually, this is part of Boston Public Library System. And the author is Peter Coles. Pita. Coles. C-O-L-E-S. Do it Tuesday. I'll be in another state and I'll be bored. Okay. Which state? New Mexico? We can do it Tuesday. I have an interview on Monday anyway, so I'll be a little nervous. I will try again later today and Monday as well. Don't do it right now, Steven. It's too late. Gotta be in San Antonio for work. San Antonio! It's a good city. I feel like you go to San Antonio a lot. You've mentioned this before in the live. Yes, I have an interview. Why? I'm trying to make money, okay? I do Lego monthly. I'm trying to make money, and even then I'm struggling with the property taxes, okay? Just so you know. Just so you know. I don't know if it's that good of a job, to be honest. I'm just trying. I'm trying. I don't know if that's good of a job. I don't necessarily want a very good job, as in a job that will suck my soul out and like take all my time, and it is related to my degree, or so it says, you know. I'll find out more on Monday, but I don't necessarily want a job that like takes up all my time. I can't do anything, and I like belong to somebody. But I did find out that I need to make more money because my bills are high and getting higher, or they did get high, higher. Heck yes, best of luck from Miss Rita. Thank you. Thank you, I'm trying. Thank you, I'm trying. There's been some challenges with jobs for me. Like I used to pour my heart and soul into my jobs. And I tried a lot. And I did make some money, and I was good, and saved money, invested money, that's all good. But then I became more of a mid-career-y, and yeah, became like a manager, project manager, got more of that, and then like change jobs, blah blah blah. Become a nomad and move to Thailand. Seriously. So basically, at this point, I have decided to kind of not make the job be like my end-all be-all and be my whole identity, and where the job like takes over my whole life and I don't even have time for laundry, and the laundry is just everywhere. That happened in my last job, where my laundry wasn't getting done. And this dress, I probably wore this dress most of the time when I gave a talk. This is my one good dress. Work-life balance is important. I feel like, so I'm one of those people who generally, I don't know. Oh, it's 111 on the clock. It's 111. I used to gravitate towards sort of roles that don't have a lot of like work-life balance. And I got kind of burned in a certain experience, and now I am here, and now I'm trying to make money, I guess. Like I'm doing more of the things that I like, such as this, and trying to make some more money, and we will see. This opportunity on Monday, I really don't know. I've never done anything like this, and I've never, like, it's this company that I had not really even heard of. So, you know, we'll see. We'll see. And it's not like a full-time job or anything. I'm nice to everyone but mods. I'm very nice to them. Aw. So at this point, I'm like not even looking for a full-time role or benefits or anything. I'm just like, part-time is good, project-based is good, that type of thing. So we'll see. Thank you. Thank you. We'll see. We will see. Hopefully it goes well and I find out that it's a real opportunity, and and that I can make some money so I can pay the bills. I hope so. I don't even need to be that rich. I just need to be rich enough to pay the mortgage comfortably. I've been draining my savings too much by taking a break from real jobs. So yeah. So yeah, I had my whole like graduate career, then like real job after real job, and I never really took a break until now. So, but anyways, we'll see. Hopefully I can pay my bills going forward. Hello, Norris. Show you how money focused I am. I've wondered how you've been doing this for months. Hi, Norris. Is something wrong with Norris? Honey, are you okay? So, ooh, there's 13 people and 17 likes. Hi, hello, thank you so much for joining. Can you please like the live? Can you like the live, and can we get 20 likes? So, I'm very passionate about whatever I try. Like, what I realized with the corporate jobs is that ultimately, like, they don't really care about you, right? You're just kind of like working for somebody, and you don't always get to like work on your own goals and such. So I basically just like saved money and took a break and went for like what I actually like doing. And I wanted to talk about physics, talk about these topics: astrophysics, astronomy, cosmology, cats, and just kind of go for it, you know? And it's been good because I learned a lot about like sort of these online platforms and how it works, and the brands, and you know, all these different things that the platforms have to offer, which is difficult to explore while having a demanding job. So it's been kind of nice to like, it feels like a lot to consider when you're like used to having a job, but when you having a job also costs money. Yeah, like I used to have to like order from Uber Eats a lot, for example. I had no time, or I had to just like pay for conveniences a lot. I would get stressed out a lot. I put a lot of wear and tear on my car a lot. I sold my car. That's the other thing. I had a very nice car. It was probably the only thing that I got attached to, because I don't usually get attached to things. Oh, I have to charge my phone. Oh, it's gonna die. I'll keep chatting for a bit. Usually, I don't get attached to things Yes, I sold my car. Yes, it was a very nice car. Had to sell it. I may have to sell the house if this doesn't work out. Let's see. Adam is saying like a cog in the machine. I prefer small teams or by myself. Me too. I also prefer small teams, but I ended up working on it for very large institutions or large sort of companies with a lot of politics. Ray says, quit a job to become a full-time yapper. Exactly. Thank you so much for understanding, Ray. Can we please get 20 likes? Thank you so much. I love the county library where I live. It's an old home converted for the county to use. I love my local library too. I love the libraries around the Boston area. You sold your car? Yes, I did. I sold my soul to the devil. Exactly. We've sold our souls, Doro. Why not sell a car? I just walk everywhere now. I walk, I take the bus, I take the train. I take the bus to the gym. So yeah, I do like being a full-time yapper a lot. Went from a small team. Now I'm part of a super large team. It blows sometimes. Yeah, I've worked in like large companies with small teams, big teams, all kinds of teams, and it's kind of like, it was kind of like all the same. Like I wasn't necessarily feeling extra fulfilled. And so I thought I'll do something for myself and see how that goes. And I've kind of liked it. Got to know you guys. Got to do this. Got to talk about physics, which I love, which is my favorite topic, along with cats, with thanks to the universe. But I never took a break until this. And I find critical thinking doesn't really take place in huge teams. It's like a lot of automatic behavior and it's kind of scary. What's your LinkedIn? What's my LinkedIn? It's just my name. Oinery. Actually, I don't know my LinkedIn. I think it's just my name. Oh, wait a minute. I used to post on LinkedIn a lot. With my blog, I think I gave myself a particular LinkedIn. What is it? It's probably my name. People are gonna look you up now. Oh, who cares? I'm not that famous. It doesn't, Adam. They don't ever appreciate free thinking. Oh, yes. That's the other thing. I did not like that you can't really think for yourself too much. Especially if you're on important projects, they don't like when you think outside of the box or when you think for yourself. So that was really traumatic for me. Beautiful specimen says completely insane. What are you talking about? People are gonna look you up now. I didn't say my LinkedIn because I don't even remember it. That's how little I've been on LinkedIn. But sometimes people message me and that's how I'm getting this thing on Monday. So we'll see. I hope it's just like part-time and I can make a little bit of money and that's it. And I can learn something new and continue to do YouTube and my live streams and read and talk about physics and cats and music and cosmology and astronomy and astrophysics. Those are my favorite topics. Steven says friendship is overrated. How? Dumbest mistake I ever made. Look at me, up the freaking ladder. I know Doro is like the boss of everybody at his company, and everyone shivers in fear of him. Become a nomad and move to Thailand. I love that suggestion. See, I cannot become a nomad because I have children who are feline but still children, and they need shelter and they need stability. So I need a home and everything. So I need to like be able to pay for the home. I have been using the library a lot. Honestly, when you don't have a job, you have more time to like figure things out and be more resourceful. So like, for example, I figured out selling the car, right? And I like waited and I tracked its price, and I made sure that like I was tracking the price and that I was like gonna get a good price. When you have a demanding job, when do you have time? Like all you can do is just kind of decompress after your job and go to bed, right? But when you don't have a job and you are recovering burnout, you might have a little bit of time. So I figured out selling the car, some other stuff that I did to secure finances for a little bit, and I decreased my costs with touch wood, with thanks to the universe, you know, because I don't have costs of going to that job. And I eat chickpeas every day. So I live on the beans. Love it. What if they ask your personal opinion on the expansion of the universe? You should prepare your answer with us. I sold my car too. Oh, Ray! Wow. Would you ever have human children? When do you ever talk about music? Oh, I don't talk, but I sing sometimes. People are gonna look you up. Good luck on Monday. Thank you, Doru. Get rich. Thank you. I don't know if their plan is to make me rich, but I do hope that they pay something for something. It is physics related, the job, but I have to figure out what they want. Is having a job the only way to be together? YouTube doesn't pay. Do you work for YouTube? Touch wood means like knock on wood. I had to buy more. Oh my gosh, Ray. Okay, this is at a weird angle because I'm charging the phone. Any other comments? So, I'm still here. Do you believe in spirits? Like soul, spirit, spirituality, you mean? Sure. I think so, yeah. Why do you ask? Let's keep reading a little bit. Other classical tests involve using the properties of very distant sources to probe directly the rate of deceleration or the spatial geometry of the universe. Some of these techniques were pioneered by Hubble and developed into an art form by Sandage. They fell into some disrepute in the 1960s and 1970s because it was then realized that not only was the universe at large expanding, but objects within it were evolving rapidly. Since one needs to probe very large distances to measure the very slight geometrical effects of spatial curvature, one is inevitably looking at astronomical objects as they were when their light started out on its journey to us. This could be a very long time ago. Indeed, more than 80% of the age of the universe is commonplace in cosmological observations. There is no guarantee that the brightness or size of the distant objects being used had the same properties as nearby ones.
because of the possibility that these properties change with time. Indeed, the classical cosmological tests are now largely used to study the evolution of properties rather than to test fundamental aspects of cosmology. There is, however, one important and recent exception: the use of supernovae explosions as standard light sources. By the way, this is something we talked about. We did look at a number of supernovae data and use them as standard light candles to figure out about the expansion of the universe. By the way, from a different book, we looked at this example. The use of supernovae explosions as standard light sources has yielded, so sometimes that's called standard light candles, has yielded spectacular results that seem to suggest that the universe is not decelerating at all. It's in fact expanding. So this book is old, it's from 2001. So since then, I believe we absolutely saw from the supernovae data, which we used as the standard light candles, that the universe is expanding at pretty much the critical rate. So it's not gonna be recollapsing as far as we know, okay? Next are arguments based on the theory of nucleosynthesis. So by the way, this Big Bang nucleosynthesis stuff is another thing that we have also mentioned in the past. And we can do that again. We can also mention it again. Because knocking on wood was meant to keep mischievous spirits from overhearing your plans. Oh, that's good to know. I don't think I knew that. Thank you for enlightening me. What kind of physicist believes in spirits? A spiritual one. Have you heard of decompartmentalizing your life? You can be spiritual as well as a physicist, all at the same time. Okay? I'm a Hindu that eats beef, all at the same time. Duality. Multi-state person. A very multi-state person indeed. I don't like the angle of any of this. Putting this back on the chickpea can right there. We learned a lot about. Well, thank you for being here to learn about me. You have the best name because knocking on wood, I solved the three-body problem, and my theory of everything also proved the beginning of time, aka the Big Bang. Hi, the Diz, the Dot. Hello, the Dot. How are you? Thank you so much for being here. Can you please like the live? Could you give us 20 likes? I thought that somebody was asking me to give them the there is Baji being so cute. For whatever it's worth, I can relate to that. Thank you. I know people judge me. I think in my personal life too, people are judging me for taking a break and going for what I love doing, and oh, that's not going to pay money and this and that. But I don't really care. Those people are not living my life and paying my bills. Like I don't depend on these people, right? So I don't really care who judges me, as long as you're not paying my bills or you're my daddy, and by daddy I mean biological daddy, or like granddaddy, great-granddaddy, great-great-granddaddy, or mommy. I don't really care who judges, because I feel like a lot of people who are judgy basically have like never gone after like their dreams and wishes, and so it's easy for them to judge, and also they're not in my shoes. They've not had my same experiences. It burns me out all the time. Luckily I have good people like Grimmy around to help out with that.
Well, that's nice. If you can get something from nothing, then you can't just go from 0 to 1. Adam, I love that emoji. I almost quit a few times. Grimmy stopped me, but eventually it can kill you if you let it. I totally get your break. I'll be your dad. I have a daddy, a biological one. Thank you, God. I think he's a little worried about me too, with my, he was very, very proud of my very successful career. And then I got burnt out. So, that's true. My dad is Kamala Harris. But yeah, basically like at my very, very first corporate job, I like pushed and pushed. Thank you. I pushed and pushed for a promotion because I thought that that's what I wanted. And I got the more, like I was already doing the more responsibilities. I was already doing the extra work. I was already managing. I already had like people under me that I was helping out. Like during the pandemic, like I was making sure everybody was good and they had work and they had projects and they were billable. Remember the word billable? I don't know if that resonates with anybody here. But at my first job, I was at the type of job where I had to be like billable. Like I was like billable from day one, and the clients loved me and I had all this success, blah blah blah. So I was like, well, I want to be promoted. I definitely want to be promoted. I'm deserving of this. I will be promoted. Yeah, do you get it? Doro, billable. So I was very billable, and I got younger people coming into the company as their like first job, second job. I got them billable, okay? And I trained them, made them into people who are billable, all this stuff. Then I became a manager, a job lead, blah, blah, blah. And I only got like a 6% raise. And I was told that there was this guy who was sort of, he joined a bit before me, but he was not going to be promoted, and he like nobody liked him. Basically, he was like the type of guy that nobody wants to be working for. So they didn't want to promote him, but he made a lot of noise. He was like, I want this raise, I want this raise, I want to be promoted, I want to be. So then he was given a raise, and guess what? His raise percentage was like higher than mine. So because I was already doing all of that work, they knew I would be doing the work, and they gave me a promotion. So I got the bigger title, but like my raise was only 6%. This is just for like as a PSA, that your raise isn't always that big when you get a promotion. So I got a promotion, but my raise was only 6%, which is not even that high. So like my salary wasn't like a lot more, but I had a lot more work. But then that's kind of how I was. That's kind of how I am. Well, hopefully not anymore. I don't like. In order to stop being that, I had to like step away, step down. But yeah, 6%. Yeesh. What does that mean? Too low, right? Too low? Anyway, then I exchanged jobs. I went to another job with, different responsibilities. Actually, my clients hired me on, so I became sort of like a client-side person. There, I became like a PM, like a program manager. So from technical, became like more managerial again, so like more responsibilities, but also more lonely. Like as a manager, it's kind of lonely. because you're not part of like the team of people who are working and solving problems together and like messing around and having fun. You have to like lead that team, and you have to be responsible. And you can't do the technical work because they're doing it, and so if you do it, they're going to be like, oh, that B word is interfering with our technical work. And so you have to like really like just like step back and let them do it, all this stuff, right? So it was a little lonely. Is this making any sense? Being a manager is lonely, yes or no? GPT is going to make a lot of bad theories and a lot of bad software. It's going to be fun to watch. I love you. False again. Chat GPT is alive. Are you going to marry me? Hello, Iswolf. Anyway, that was that job. Then, you're in the AI Sentience Club. I don't know what's happening with this AI stuff. Being a manager is definitely lonely. You lose the camaraderie over time. Exactly. Thank you. Thank you. And the people who were in the team were like more senior to me. Some of them were more senior, some of them were more junior. And I remember like there was one time like we went out to eat, and I organized like this dinner, and they all loved it. And and they were like, oh, no, none of the PMs like do this, and then I talked about Instagram, and they were like, you do Instagram? How old are you? Oh. So the man known as Grimmy, maybe 3 others, and my secretary. That's it. That's all I talk to at work. I know! Nobody talks to the managers as much. And like I could be friends with the other managers, but they were all so busy. They were all running around doing their manager things. And Ace Wolf, what's going on? How are you? And yeah, so you get it. Being a manager is lonely. Okay, next job, because I've job hopped a lot. I'm basically a job hopper. So whoever's interviewing me on Monday knows that already. So like, dude, you get it. If you're watching my videos, you already know I'm a job hopper. So better come with a good deal or don't waste my time. Like I'll literally sell the house and do YouTube. I already sold the car. I already sold my one thing that I loved. Because I usually don't love things. I love experiences, cats, physics, astronomy, cosmology, you know. The car was the one thing that I liked. Otherwise, I don't like things. Now I don't like anything. I'm not attached except for the home. Thank you, universe, for the home. Thank you very much. Not thank you to Chase Bank for being, you know, escrow analyzing the frick out of my freaking things, but whatever. Andrew is spitting facts right now. Wish Grimmy was still here. He would relate with this too. Yeah, so anyway, being a manager was boring. Or not boring. Did I say boring? Boring and lonely. It was nice in the sense of like having a lot of authority and freedom. But then what happened was managers will still have a manager, right? My manager changed. He retired. Literally the guy who hired me, come here guys, come here. Just listen, just be with me. Literally the guy who hired me, he retired. Fucking retired. This really changed everything because because what are you talking about? Because this boss of mine was nice and the new boss was not nice, and he did not like giving me a lot of freedom, and I kind of like having a lot of freedom. Catamaran, I do like catamarans. Are you offering a catamaran ride? What's happening? I do like catamarans. They're nice. Anyways, whatever, that job, I job hopped. Next job, next job. Some jobs later, here I am. But I do believe in saving money, making money, make money. Money is definitely more efficient at making money than I am. So I highly recommend that. But at the same time, it does get difficult. Like I'm saying now, like with my property taxes increasing, that's gonna make the bills higher. And so I'm gonna try to get more income coming in. But yeah, the job for Monday. I just hope that these people know that I job hopped already a lot. And I'm not looking for a promotion. And I'm not looking for a lot of responsibilities. I'm not going anywhere. I already sold my car. So it better be work from home. I'm not going anywhere. I'm not sitting in traffic. I'm not driving anywhere. That is true. I don't really want a full-time job, no. I want some kind of project-based, part-time-ish job. And I want to do my things. I love my 2003 Ford Focus Special Edition. Aww. That's nothing. At that Canadian owned company, everyone who came before me and most that came after got fired. Are you talking about an app? That's cool. Congrats on your app, The Dot. Build a company. I got work for you. I like that. Hello, Ariel. Good morning from Paris. Good morning. Good morning. Good morning to Paris. Still got access to an XTD or XRF. She thinks you're serious. Are you not serious? How can you be not serious about building an app? Easiest thing to do. Ariel says, how do you do? I'm good, how are you? It's 1:45 in the morning. Anyway. Adam, how are you doing? So Doro, speaking of burnout, yes, burnout is very real, and oh, Baji baby, and I'm glad that you resonated. If you can take a break, go for it. You can always find another job, I think. I don't know. I'll let you know. And climbing the ladder up and up and up and up. I just hope you find a way to demote yourself and find some peace and time for yourself. I won't drop the name of the company, especially now that I believe they're closed. And also, I didn't tell you guys everything that happened. So somebody was saying something like, that's nothing. Well, you don't know I haven't told you the full story. I'm giving you a gist. There is a lot that happens and happened. I think a lot happens at anybody's job that obviously we can't always talk about here. But thank you for sharing. I agree with your strategy of working less and focusing on your passions more. Thank you. Okay. Thank you so much. Yes, I agree with that as well. Like I've worked very hard at these jobs, and what I realized over time is that like the results and the outcomes that I was getting out were not really scaling with like my efforts and what I was doing and the time I was putting in, and and whatnot. And so I so far told you about the earlier jobs. At my last job, the one that triggered this break, there was a lot of really crazy things that went down. A lot of really crazy politics and stuff, which really highly expedited my decision to take a break. And I don't know if I'm ready to like really talk about that. That's actually why I didn't really talk about my whole transition too much. I'm excellent. Where are you from? Thank you, Ariel. I am originally from India, but currently I'm in Boston, in the US. Hanging in there, ma'am. Fighting the inventor of AGI right now. Be on my board. I agree with your strategy of working less and focusing on your passions more. Thank you. I take all my vacations and sick days. It helps. But sadly, I'm already pegged for the next promotion. Oh my god. Well, good for you guys. Good for you. I am impressed with my friends who are, you know, chugging away at their six-figure good jobs. Good for you, man. Like, if you like it, go ahead, go for it. I know it takes a lot of energy and it's very tiring, so hopefully you find some solace and peace at these live streams. And yeah, I have some sense of like what these good jobs entail. So congratulations. And yeah, asset-backed commodities and joint venture with 46,000. I don't like this one. I wouldn't discount your story. It gets way too real when you're invested in a high-level career. I couldn't come to your broadcast last fall on my wrist. Mohammed, oh my goodness, how are you? Yeah, there was a lot of politics at my last job, which made it very impossible for me to contribute at the level. Because like at some point when you're able to make a difference and contribute at a certain level, you want to have a bit more, you want to have more autonomy and like contribute and do work, right? And when the politics like stops you or even puts you in the doghouse, which is what happened to me, that can really suck. I was very heartbroken about that. I'm just here to say Dura's gonna be the big boss when the current guy retires. Wow, congratulations, Duro. Ugh. Just had to say that while I'm on the toilet. Wow, Grimmy. Wow, Grimmy, wow. Sharing everything now. Thanks for letting us know where you are. Where's Baji? Oh, Baji was just eating his food, so he's probably, Oh, Baji's behind me. He's over here. Oh, another thing that never was appreciated at a corporate job was my empathy. Like, I think it was appreciated to a certain level, but then when I was working with people who are like really aggressive and deploy harsh methods rather than accessing their empathy, then it didn't go so well. So, go to bed, Grimmy. Where's Baji? Adam Dolson, you gotta truly understand Grimmy. Oh gosh. Do we want to understand what Grimmy is doing? I don't know. I don't know. I don't know if we're ready. Baji! But it's been fun. It's been fun just talking about